Good morning. Can you hear me properly? Yeah. So I really liked the first presentation, especially the description of the future where all the devices will be connected, and the potential threat of that, like having wrong decision from all those machines, and how to prevent that from happening. So, and that's a bit what we are trying to do at Softkinetic. We are trying to bring some technological blocks that we call 3D vision to help machines to understand better what a human expect from them to do. So by bringing 3D vision, you can expect those machines to understand you much better. So to anticipate better what you want them to do, and to have a better way to interact with them. So to achieve that vision, we are developing technological blocks that are software-based and hardware-based. So at the core of our technology, we have a sensor, a time-of-flight sensor that we design. Then we have our camera design, and then we develop a bunch of software to track human gestures, to do a 3D reconstruction, etc., etc. And we also focus on use cases. So we are a hardware company and software company. And our business model is not selling products to a consumer. It's licensing our technologies to OEMs and companies that have the ability to bring product to the market. So maybe a quick word about time-of-flight. So that's an active technology. So it means we have an infrared emitter, and we are basically measuring the time that the light takes to do the distance, getting out of the camera, bouncing an object, and returning to the sensor. It's not exactly the time, it's more the phase shift that we're measuring, but you can derive the time out of that. So our technologies are on the market already today in a bunch of products. First is Texas Instruments, who is manufacturing our sensors. We have Intel using our cameras and our middleware for close interaction on PC. We are in the PlayStation 4 for the full body tracking. So here it's only a software play for us. They have their own stereoscopic cameras. We are working together with MakerBot to bring a scanner, high precision scanner for consumers, so at a reasonable price. And next year you'll see on the street a first car with our camera on the rooftop and with the gesture recognition to drive your infotainment system. So with the 3D vision in general, what can you do? You can do a lot of things. So as I said at the beginning of the presentation, for us it's really to make machines smarter. So, and we have three big categories of use cases. What we call active control, it's really about the user controlling an interface, controlling a game, controlling a machine. We also have what we call context awareness. That's the other way around. That's the machine who look at what's happening around them and reacting accordingly. And the third family of use case, real-world acquisition, which is really about reconstructing 3D objects. But here at AWE, we focused on what you can do with the 3D vision in VR and AR. What we are exploring and trying to bring to a VR experience is a natural way to interact with the virtual space. So today you still have to use your keyboard, mouse, or gamepad, which is really disconnecting you from the experience. And so by bringing that 3D vision and natural interaction, we try to get closer to the buzzword, the presence, as it has been defined by Michael Abrush and Richard Marks from Sony, to really make that connection much better between the VR space and what the user is doing. So I don't have a live demo here, but you're welcome to check out our demo on our booth. But I'll try to launch that video here. just to show you. Well, here. Oh, so this is a very basic test where you interact with your hands in the VR space and you can manipulate objects, modify, construct different things. So that's available on our booth, so please check it out. So a quick word about what is the challenge for us in VR. Those are three really basic and obvious challenges: latency, field of view, and tracking fidelity. So latency is it's a very long pipeline, you know, from what the user is doing to at the end the display in the Oculus in this case. But that's also a lot of opportunities to improve and to reduce that latency. So today we have from the moment of the user is moving up to the moment where the sensor is delivering a depth measurement, it's 60 milliseconds. And then all the rest of the pipeline takes a lot of time, 15 to 60 milliseconds. And again, Michael Abrash thinks that 20 milliseconds for the whole pipeline is the maximum. So we are not there yet, but we are working hard to get there, and we know that we can achieve that at some point. Yeah. So field of view. I've got lag on my laptop here. Yeah. Field of view with our product on the market today, we have a 70 degrees horizontal. We need to go to at least 120 degrees. And again, time of flight is a very flexible technology to do that. We can change the optic quite easily. So this is not a major challenge for us. And then tracking fidelity. Obviously, you need to have a very realistic interaction. And again, here time of flight is a interesting technology to provide you a real 3D mesh of your hand. First version was a grayscale. Now we try to also texture with the RGB feed to make it more realistic. So David brought a small sensor. I also have a very small sensor. You can see on the picture on the Oculus thing, that was our big fat camera, but we have a new module here, super small. It's working on our booth, so you can also check it out if you want. That's it.
Thank you very much. Thank you. We have time for some questions.
I noticed you mentioned field of view, latency, and tracking fidelity as your main challenges. What about power, thermal issues?
So power for VR is not so much a challenge because it's still connected to a non-mobile platform. As soon as you go to mobile, then power is indeed a big challenge. We're getting there as well. You know, the new module consumes 800 milliwatts, which becomes acceptable for a mobile platform. We know we can go much lower than that, but it's a matter of engineering.
Questions for Eric?
Really quick, I'm just curious, when is the next generation? I've been by the booth a couple times and had a chance to play with the demo. But when's the next generation camera coming out?
So it's there. So it's not in a commercial product yet. As I've explained, we are not selling product to consumer. So we're working with OEM, but the modules are there and in production for the moment. Yeah.
Can you talk about the limitations of the distance? Like we know the Leap has.
Right. So again, that's a very interesting, time of flight is very interesting technology because there is no theoretical limitation in distance. I mean, it's just a matter of illumination power. If you put more illumination, you can go 10, 100, 1 kilometer away if you want. Obviously, here we are targeting consumer devices, so we have a power limitation. So here, today, I mean, reasonable assumption is that it's going to be 5 meters, something like that.
Any other questions for Eric? Well, thank you very much.
Thank you.